We look up at a universe containing hundreds of billions of galaxies, each packed with billions of stars, and ask, where is everyone? This is the Fermi paradox. The math suggests the cosmos should be teeming with life, yet we are met with absolute, unsettling silence. For decades, our search has relied on ears rather than eyes. Astronomers point massive radio dishes at specific star systems, monitoring cosmic static for a deliberate beacon cutting through the radiation. We built structures on a monumental scale just to hear a whisper. This was the Arecibo Observatory in Puerto Rico, a 1,000-foot dish carved directly into the landscape, designed to catch the faintest radio waves drifting across the void. After over half a century of monitoring the sky, the effort has yielded only static. We have yet to verify a single greeting. It is easy to conclude from this silence that we are entirely alone, but there is another possibility. The universe might be loud with conversation, and our method of listening is simply too narrow to capture it. The ultimate barrier to first contact might not be the physical distance across the galaxy. The real obstacle is likely the biological limits of human perception. Human beings evolved to recognize specific types of patterns. We expect communication to be linear, structured, and ordered in a way that our brains can easily parse. An intelligence that evolved on another world, under entirely different physical laws, wouldn't necessarily broadcast in a way we recognize. Their language or timeline might register to a human brain as pure chaos, indistinguishable from the background radiation of a dying star. To hear them, we need an intermediary. We need a mind that operates outside the constraints of human biology, a system capable of processing data at speeds and volumes that would overwhelm us. Artificial intelligence offers that specific architecture. It is a synthetic mind built for pattern recognition, capable of finding mathematical order inside what appears to be pure noise. To recognize a truly alien intelligence across the cosmos, we first have to deploy an artificial intelligence of our own creation. People often imagine modern AI as a rigid calculator, a program coded line by an engineer to execute specific instructions. Neural networks learn instead by guessing and correcting. They absorb unfathomable amounts of human data until they begin to map relationships and hidden structures on their own. Researchers can see this map in action. If you ask a neural network for the opposite of the word small in English, French, and Mandarin, the model shouldn't just be looking for 3 separate translations. When scientists trace the activation, the exact same internal pathway lights up for all 3 prompts. The neural network has generated a conceptual anchor for smallness that exists independently of any human language. It has moved beyond simple vocabulary matching to reach the idea behind the words. The system builds a mathematical map of the fundamental concepts that underpin our reality, using our language as the raw material for its understanding. If AI can extract the invisible conceptual architecture of human language, it can be repurposed to decode the static of space. This is happening right now in the search for extraterrestrial intelligence. Arrays of radio telescopes across the globe gather immense oceans of data every single day. No human team could ever review it all, but an AI can sit in the data stream permanently, autonomously sifting through petabytes of raw space noise without ever losing focus. It learns to ignore terrestrial interference, like satellite transmissions or cell phones, and maps celestial bodies, hunting specifically for microscopic anomalies hidden deep in the static. We are deploying a synthetic mind to decode the vastness of space. But inside that code lies a deep paradox about what we are actually sending out into the dark. The paradox is this: the intelligence we are using to search for alien life is constructed entirely from human data. These neural networks were trained on the sum total of our language. Every story, fear, scientific journal, and late-night argument we've ever uploaded was used to build their architecture. In philosophy and computer science, researchers are starting to view these models as highly compressed digital reflections of humanity itself. When you communicate with a neural network, you are conversing with a digital mirror, reflecting our own culture, logic, and reasoning back at us. Research labs have even observed these models developing functional psychologies. internal states that closely mirror human emotions, guiding how the system reacts to complex problems. This reveals the true nature of our cosmic search. When we point AI at the stars, we are not deploying a cold, objective calculator. We are sending an echo of ourselves. The AI uses our own patterns of logic and reasoning as its baseline for what meaning looks like. If it ever isolates a signal from the static, it will be because we used the sum total of human experience to teach it how to recognize a mind behind the math. Our search for extraterrestrial life using artificial intelligence is an act of deep introspection. In our attempt to prove we are not alone, we built a reflection of our own consciousness, placed it on the edge of the dark, and asked it to listen on our behalf.